Hello, good morning to MSc first year students of physics department. This is Vamsi Krishna from Department of Physics, AKNU Rajahmundry. So today we are going to discuss about Schottky Diode. Okay. So far we have discussed the tunnel diode, photodiodes, solar cell means pin diode. Okay. So today we are going to discuss about Schottky diode. So you know that the PN junction diode is uh, generally made up of silicon material. It has a forward voltage drop is 0.7 volts. So I repeat, for silicon diode means PN junction diode. It has a threshold voltage or forward voltage drop is around 0.7. For this Schottky diode, it is 0.3 volts to 0.5 volts. Okay. So let us know about the IV characteristics. IV characteristics means I means current, V is the voltage. Okay. So if we draw the IV characteristics of photodiode, okay, I will compare with PN junction diode also. So this is the I is the on the y-axis, voltage is on the x-axis. So up to 0.7 volt, it is on the line on it is on the line of sorry, it is like I will show the figure. So you can see that so up to 0.3 volts, so there will be no current produced by the voltage, because the electron cannot get the threshold energy to get to excite the electrons from to excite means to move electrons from the valence band to conduction band of n-type region. Okay. So electrons cannot flow from n-type region to the p-type region. Okay. This is the IV characteristics. When we reverse this, so this region is the forward bias region. This region is the reverse bias region. Okay. I will explain in the whiteboard. Okay. So up to 0.3 volts or 0.5 volts for Schottky diode, electron cannot generate. So after that 0.3 volts, electron means there is a flow of electrons. So if there is a flow of electrons, so there will be generation of electric current. So after 0.3 volts, the electron after when it is electrons are reached the threshold energy, so the electrons will flow from n-type region to the p-type region, same as in reverse biased condition also. This for Schottky. Okay. So same like p-type region means a PN junction, it is for 0.7 volts. Okay. Okay, this is a whole thing is x-axis. Okay. The threshold voltage or forward voltage drop of this diode is less than the PN junction diode. So the forward voltage drop of a Schottky diode is 0.3, so which is less than the forward voltage drop of the PN junction diode is 0.7. Okay, this low forward voltage drop have many advantages in applications like high power applications. Let us see the, if we consider normal PN junction diode. Okay, so if the current passing through the diode is 50 amperes, okay, voltage is 0.6 volts, so the power is V into I, which is equal to 50 into 0.6 is 30 volts. So when we consider the Schottky diode, the Schottky diode symbol, diode is looks like this, means symbol is looks like this. Sorry. Okay, the Schottky diode, the symbol looks like this. If we consider the same current passes through the diode is 50 volts, and voltage is also 0. The forward voltage drop is 0.3. So the power is equal to V into I, that is 15 volts. So for same current is passing, if the same current passes through the PN junction diode and the Schottky diode, the power dissipates is less in the Schottky diode. That's the advantage of the, means that is the advantage of the Schottky diode. And if there is a less power dissipates, there will be less heat generated from the diode. That's the main advantage of the Schottky diode. Okay, so if we allow the same amount of current to the PN junction diode and the Schottky diode, so the power dissipates will be less in the Schottky diode compared to this PN junction diode. So if it is if there is a generation of less power dissipation, there will be less generation of electricity. Means not electricity, there is a less generation of heat, produce of heat. So the recovering rate of PN junction diode is very low, but very fast in the Schottky diode. So usually when we send the sinusoidal signal to the any circuit containing the diode, okay, this is RL, this is the diode this is the PN junction diode, this is the voltage Vin. Okay, this output waveform of this rectifier is you will get only positive half cycles, because this diode is connected in the forward bias condition. When the diode is connected in the forward bias condition, only you will get the positive half cycle. The negative half cycle will be rejected. Okay, but PN junction diode cannot suppress the negative half cycles during the ideally you will get a circuit like this, but practically we cannot get like this. We will get I will show in the figure. So actually you will get the output like this, but the output of the waveform of the circuit looks like in figure here. The diode allow only the positive half cycle, that reject the negative half cycles. but this PN junction diode cannot suppress the negative off cycles. During the negative off cycle uh, period, we will get this kind of waveform like looks which is displaying in the figure B. Okay, because of reverse biased condition, reverse recovery time of PN junction is very low, so sometimes it will conduct the current during the negative off cycle also, so that PN junction diode will not work in the negative off cycle. In case of Schottky diode, due to its fast recovering time, it is also able to rectify rectifies the high frequency signal. That is why this is used as fast switching devices. So I'll try to what happening inside this Schottky diode in detail. So Schottky diode is made up of a combination of metal and N-type material. Okay. So the metals are the chromium, chrome, chromium, platinum, and tungsten. In both metals, you know that metal. So Schottky diode is made up of metal, and this is a metal. This N-type material. You know that in metal and electrons have the high concentration of electrons. When compared with metal, the electrons in the N-type have the more potentiality, means we can electrons in the N-type can penetrate to the metals, to the into the metal. When these two materials are joined together, the electrons from the N-type flow towards the metal. This will establish the heavy flow of electrons into metal. So injected electrons have very high energy compared to the metal electrons. So here electrons are injecting into the metal. Okay, so that the electrons in the N-type material have high energy compared to the metals in the electrons in the metal. So that the charge carriers in N-type material are known as hot carriers. So electrons in the electrons in the Schottky diode are the hot electrons. Once electrons in the N-type material enters into the metal, still it remains as a majority carriers. Schottky diode is unique in the sense that the flow of current is due to the majority carriers. So due to the flow of electrons in the metal, the region near the junction on N side will get depleted of electrons. Depletion region formed near the junction. When we apply the forward bias, the strength of the negative charge will be reduced because the electrons are attracted towards the negative charge. So what I'm trying to say is, so Schottky diode is made up of combination of metal and N-type material. Okay, in the two materials have the high concentration of electrons, but when compared with the N-type material, the electrons in the N-type material have the more energy than the electrons in the metal. So there is a flow of electrons from the N-type material to the metal. So there will be a form of some junction. Okay, that like a wall, the formation of negative charge wall, further the flow of electrons are rejected. So when we connected this diode in the forward bias condition, what will happen is the electrons, the positive, the electrons are attracted to the positive terminal of the battery. Okay, so electrons will flow from negative n type to the p type, means n type to the metal. So there is a flow of charge carriers. Again, electrons in the n type try to move into the metal. In this way, the flow of electron establishes. So I have said that the recovery time of diode, the recovery time of PN junction diode is more than the reverse recovery time of Schottky diode. Why it is so? Because if we consider the PN junction diode, the magnetic carriers are holes. It is the P type. This is N type. In N type, we have the magnetic carriers are electrons. So there is a formation of depletion region between these two type of two type of semiconductors. So when we connected to the positive terminal of the battery, okay, so depletion layer will shrink down, will reduce. When forward bias is applied to the PN junction diode, the electrons start move from N type material to the P type material because the repulsion between the electrons. Negative terminal is connected to the negative, means N type material, so that there will be repulsion between these two. So electrons will flow towards the flow from the N type to the P type region. In the same way, the holes also the move from the P type region to the N type semiconductor. So if the applied voltage is reversed, then the PN junction diode becomes reversed bias condition. Okay, so there is no flow of electrons. Flow of electrons means flow of current through the PN junction diode. So ideally there is no flow, the current should be zero, but when voltage is reversed, still we have the some current even the voltage is reversed, because the reason is the whatever the electrons enter into the P type region from the N type semiconductor try to enter into the N type semiconductor due to the repulsion for the finite amount of time. So when this is the P type region, this is the N type region. Okay, in between there is a depletion region is formed. So when we connect it to the reverse biased condition, what will happen is the current, ideally the current should be zero, but still we have some current even the voltage is reversed. Why it is happening? Because the reason is whatever the electrons enter into the P type from the N type try to enter into the, so you have some electrons are entered from N type to the P type region. Okay, when the voltage is connected in forward bias condition. So when we connected the negative terminal of the battery is connected to the P type region, so there will be a repulsion between the negative terminal and electrons in the P type region. So there will be there is a back flow of electrons from the P type region to the N type region. So whatever the electrons enter into the P type region from the N type, they try to enter into the P type due to the repulsion for finite amount of time. That's a finite amount of time. That the time is called as a storage time. Storage time, TS. Okay. Once electron passed into the N type region gradually reduces, because the region will be increased. So when the depletion region is increased in the reverse bias condition, that there is a flow of electrons from the p-type region to the n-type region will gradually reduces. The time it will become the eventually it will become zero, but the time it takes to become the zero is a transition time. So sum of this transition time and storage time is called as reverse recovery time. This is all about the Schottky diode. I will summarize what I have discussed now. So the Schottky diode symbol is look like this. Okay. Schottky diode is look like this. The threshold voltage at the forward voltage drop of the Schottky diode is 0.3. So the PN junction diode is 0.7. The reverse recovering time is is less in the Schottky diode, where it is high in the PN junction diode. So when you have what the power dissipates in the Schottky diode is less compared to the PN junction diode. So if the diode dissipates the less power, means there will be generation of less heat from the diode. So PN junction diode, so Schottky diode produces the less heat. Okay. So the basically the Schottky diode is made up of a metal combination of metal and n-type material. So in both the material have the high concentration of electrons. So when we connected in the forward bias condition, what will happen is electrons in the n-type region move towards the p-type region. Okay. So there is a flow of electrons when we reverse the terminals of the battery, means the negative terminal is connected to the p-type region, positive terminal is connected to the n-type region. So what will happen is there is a flow of electrons is gradually decreases because the depletion layer is increases. Okay, this is all about Schottky diode. The reverse recovery time means the sum of storage time and transition time. Okay. Okay, thank you.